I forgot to record it. Okay, now I'm recording it. Okay. So our task is to write the script for modified secant method. Okay. And for the modified secant method, keep in mind the um, equation. So this is the equation, right? So xi plus 1 is equal to xi minus delta into xi fxi over this. Okay. So this is delta xi. Remember that it is not one term. Delta is separate. Xi is separate. Okay. And then delta times xi. Okay. So in MATLAB, so this is the comment I have written. Okay. So maybe we can start from the because of course this kind of process involves the repetition. So let's assume the stopping error is say 0.001 or 0.001 whatever. Okay, so this is the stopping error, and then I put it like this. And then suppose that this is the first iteration, so I will put I is equal to 1, and then take the initial value x0 is equal to say 1, but what is the function which I am investigating it? So the function which I am investigating it is simple, at the same as the example in the book. Okay, so the function is f of x is equal to e power minus x minus x. Okay, so suppose I want to find the root of this function, e power minus x, right? So this is the function. So just suppose that it's the initial value which I want to start in the root is 1. Okay, and now I can define the function in the term in the term of function handle, or even you can just write the function in terms of the full function as well. So whatever way which you feel comfortable, but maybe I can use the function handle approach. So I can use that f is equal to at x. So this is the function handle, which shows that this function is in terms of x. And then what is the function? E power minus x. So exponent. So exponent is the MATLAB function exp minus x, and then minus x. So it will be in this way we can define this function. Okay. So according to the formula for this modified secant method, we can see that what we need to for these iterations. So we have the x we already defined, and we need delta. So delta we need to define. Okay. So let's put delta. So delta maybe I can represent with say d. Okay. So d is equal to say 0.01. So it has to be a small value. Normally it is normally taken as a small value. And here I can put a comment that d represents delta. Okay, delta in the formula. This is the comment. Okay, d is equal to 0.01 and f is this one. So the function. And then what else we need in this modified secant formula? So we need the value of the function. Okay. So because we have already defined the function handle, so we can just put it like this. Okay, f x0. So then it will define it. And all the other values are there in this function. So now we can define this formula in this MATLAB. So here for this I can put like from x0 we will get x1 value, right? So x1 is equal to x0, okay? Yeah. So this one, x1 is equal to x0 minus delta times this. So go back to here, x times 0, x0 minus delta. So delta is represented by t times x0 times function at value x0. Okay, so this is delta xi fxi. Okay, so this is delta fxi xi fxi. Okay, and then divided by delta fx plus delta into xi minus fxi. So divided by, and now I will need to put parentheses, function x at x0 plus delta, that is d times x0, and then bracket close. And that is that bracket is for the function handle, and then minus f of x0, and then again the bracket close, that is for this bracket, for the bracket for the denominator terms. So yeah, minus f of x0. So in this way, hopefully I have defined this function correctly over here, and then I will close it by the semicolon to suppress the output. So, in this way, I have identified the first iteration. So what is this first iteration's absolute error? This first iteration's absolute error will be equal to absolute, and then I will put the parentheses for the absolute terms, and then the change of value will be from x0 to x1. So x1, so it will be x1 minus x0, and then divided by x1, okay, and then times 100, so to represent it in terms of percentages, okay. So in this way, I will represent the EA, which is the absolute relative absolute error, okay. So relative absolute error. So what I can do is now I can put because now I want to show the results, so I can use the fprintf command to show the results. So first command over here will show the heading of the table, okay, the first row or the heading row of the table. So fprintf, okay, and then inside of these apostrophes, so I will use the iteration, this which will show the iteration number, the heading xi, the heading xi plus 1, so updated value, the value of that function, and then the absolute error, and then /n is to show that this will be the end of the line, and then the next output will be on the next line, okay. So yeah, so up to now, I think we have written this command. Then it maybe it is a good idea to check this script as well. So for this, maybe I can save it like modified secant. I will put lab. So I'll put this name like this. So modified secant lab. So I have saved it, and now I can run it. So when I run it, I can see that it has only displayed this iteration xi, fxi, ea. Okay. So this is what up to now, which has been done. And then although it has calculated a number of things as well, but because I am not displaying it they only appear into this workspace. Okay, so up to now it appears okay. But if I want to print the first result over here, I need to add one more line over here, and that uh, one more line will be this. So that will be another fprintf command. Okay, this one. So, and in this fprintf command, I will, as I have explained before, these are the %d and %f. These are the formatting. Okay, these are the formatting. These are for the show that the what type of output I will show, and then what type of formatting will be there. But here, this is important. Okay, this in the square brackets, because this will determine what I want to show. Okay, over here in this brick. So this is the vector which I want to show. So this is I is the iteration number. So this will come from here, and x naught will come from here. It is the initial value, and x1, that is the calculated value, and then fx1, that will be the value of the function at the calculated value, and then ea, that will be the uh, what is ea? Yes, what is ea? Ea is, hello, anyone listening?
Error.
Yeah, absolute relative error. Okay. Okay, so now I have put this command, so let's check it. Okay, so for checking, it is better maybe I can clear this workspace and then run it. Yeah, so after I check it, so then I can see that I get this first iteration of value. Okay, so initially I used the value of 1. From this value of 1, we got a result of 0.53726. And then at this result, the value of the function is 0.04. Okay, it's already quite close to 0. But in this case, the relative absolute error change from the previous case was 86.128. Okay, so but we can do some more iterations. So for doing these more iterations, we need some loop. Okay, and we should make sure that the loop should not be wrong. So we can put a loop of while EA is greater than ES. Okay, then I is equal to I plus 1. Then that means that will be the second iteration. And then for this second iteration, we need to calculate the value of x. So this value of x will be the same as calculated from this formula. Okay, as calculated from this formula. But here I think, yeah, the formula is correct. The formula is correct. But here I think the value of x naught should not be the same as the previous case. So therefore, there should be an updated value of x naught over here. So in order to have an updated value of x naught over here, we need to add one more line over here. And then we should put that this updated value of x naught should be equal to the value, the previously which we calculated the value for x1. Okay. If we will not put this line over here, then the value of x naught will not be updated. And then if we will run that loop, then it will run for infinite number of time. It will not finish. So we have to be careful. Okay, so anyway, so this is the one, and then after that we will calculate the uh, error, And after that, we will print out the results by the same command. After we print the results and before we exit the loop, we have to update the value of x naught, okay, for the next loop, okay, x1. So for example, over here, yeah, we have to update the value of x1, because if we will not update it, then of course the same loop will keep continuing forever. And now we will end it. And with this, I think the script is complete. So now I can run it. Okay, I have cleared the workspace and run it, and then I can see that immediately I get the result. And in fact, in this case, the result is quite correct, because we already know that for this case, the answer is 0.56714, and then the value of the function is also very close to 0 over here. The absolute error is also quite 0. So only within the fourth iteration this value has converged. Okay, is it clear?
Sorry, I missed one thing. In the line 11, how did you do that? F print F and those percentage values.
Yeah. This fprintf. So this is these percentage values. So this percent 5d. So 5 means the number of digits, and d is the code to show that it is an integer. So for example, 1, 2, 3, 4. So this one I am using for the integer. So I just put 5 digits just to provide some space for this thing. Otherwise, not like that. And then 10.5f means 10 is the number of total digits I reserve for this output, and f is for floating point. F is for floating point format. So this is the all of these values are in the floating point format. Only the first column is in the integer format. So I can use, so you can use even 10.3. So in this case, only 3 decimal places will be shown. You can use 10.8, then in that case 8 decimal places will be shown. So we have to provide as many number of times of these things over here as the number of outputs we want. So for example, here, how many outputs I want? So for example, I want I need here 1, 2, 3, 4 floating point output. So I will put 1, 2, 3, 4, exactly 4 times of this 10.5f. Okay.
Okay, thank you.
Yeah. So this line is repeated in the while loop as well, because outside of the while loop we have used the values for our initial line. Okay. And then the other lines which since we are repeating it, so then we are repeating it in the while loop. Yeah. Any more question? Yeah. So suppose if I make a mistake. So for example, if I forgot to uh, put this line, and then I run the code after saving it, then you see what will happen. So we will get this thing. So you can see that the value of the absolute error is not increasing. That means the loop is running the same line again and again and again. So when this thing happens, I think there is nothing you can do except you have to hit this close button and run the MATLAB again. So it will show you that stop now and exit. Yeah, I will say yes. Okay, and now I will run again MATLAB. So this can happen anytime, but I think we should it's okay if it happens, but you can just start the program again. Okay, so now I put back this command again and then I run the code. Yeah, so it is okay now. And similarly, if let's try from here, if I don't put it here, then what happens? Okay, then what happens? Yeah, it is, it will run, but I think you can see that in the second and the first iteration, we got the same values. Okay, we get the same values. So maybe we will get one more values over here. Or in another way, I think maybe we somehow we can compress this script into just put the while loop as well, and then maybe we don't need to write so many lines as even as well. So anyway, you can think about improving this script as well. Okay, so any question about this modified secant method script? If not, then we move to the, okay, I think, yeah, okay, I think it's, I hope it's understood. Okay, next, if we move to, say, the other script, which is the modified Newton Raphson method, okay? So we can clear this like this. So for example, if we want to clear the workspace, so you can put the command clear, comma, CLC. So clear means it will clear all the calculated values in the workspace. And CLC means we will also clear this window as well. Okay. So now let me show you the script for the modified Newton Raphson method. Okay. So the script for the modified Newton Raphson method. For this script, I will use this example. F of x is equal to x cubed minus f 5x squared plus 7x plus minus 3. But for the, if you see that for the modified Newton Raphson method, you need f prime and f double prime. That means you need the first derivative and the second derivative. So the first derivative will be f prime of x is equal to 3x squared, 3x squared minus 10x plus 7. Is it correct? Is it correct?
Yes.
And then the second derivative is 6x minus 10. Right? So we will need to use these three into this in the code. And then we need to apply this formula. Okay, so for this, what you can do is, yeah, sometimes it is easy to work from the code which you have developed. So what we can do is I have already saved this file as modified secant lab. So I can save as modified Newton Raphson lab. Okay. Newton Raphson lab. Okay. Method. Okay, and then I can change this comment as write the script for the modified Newton Raphson. So we can start from ES is equal to 0.001, okay, and I is equal to 1, and let's see what is the value of the x. But let's define the, here there is no delta involved, so I can remove this line. Okay, no delta involved here in this case. Let's define the function. So the function is this. The function is this: x cubed minus 5x squared plus 7x minus 3. So this function can be written like this. Okay, x cubed minus 5x squared plus 7x minus 3. And then we need to also define the function f prime. Okay, f prime I can represent by fp. Okay, this is also a function. You will use a function handle f prime at x, and then it will be because it will be 3x squared minus 10x plus 7. So it will be 3x squared. Yeah, and then for the second derivative, I can say f dp f double prime. F dp means f double prime, which is also at x, and that is 6 times x minus 1. So it will be 3 times 2, 6x minus 1. So 6 times x minus 10. 6 times x minus 10. So in this case, the formula is different, so it is not the same. Okay, so the formula is this. X1 is equal to x naught minus fx into f prime of x, and then this one. So I have already written it down. To save time, I think I will just copy and paste it from my solution. Yeah, this one. So yeah, this is x1 into x naught minus fx naught into f prime of x naught divided by f prime x square, f prime square minus f x naught into f double prime of x. Okay, so in this way, and the absolute error will be x1 minus x naught over x1 into 100, and then I will print the iteration xi plus 1, fxi plus 1, ea and n, and then f printf. So it will be this one. So I will print I x naught x1 fxn fx1 ea. Okay, I will print these values, and then before the loop I will initiate back the values of x1, and then after that what I need to do is actually what I can do is I can repeat these values, okay, starting from x1, and that's it. That should work. So increment this the iteration by 1, and then I can repeat these values from here. And this will make it double, so I can remove this line because this is the only use for the heading. And to just align the terms, so I will just align these values. Okay, and hopefully everything is fine in here. Okay, so now it is the time to run this code. And here it is showing that not a number. Yeah, when we have this error, not a number, it will mean that there is some, there is likely not a mistake in your formula, but there is a mistake normally in your initial value. Okay, so the initial value in this case of 1 is not a good one. Maybe we can take an initial value of, say, in this case is 4. Okay, okay, and then run the code again. Okay, so clear, and then run this script again. And now I can see that the value obtained is this. So because this was a polynomial equation with some double roots, so here you can see that the value obtained is 3 in this case. Or another value for this may be obtained as, maybe let's try a value of 0.5 as the initial value, because this is a polynomial, so it may have more than one root. So by different initial values, we can get different results as well. So 3 is one of the root. Okay, let's see if there is any other root near 0.5. So clear this and then run it, and then you can see that another value was found. Oh, sorry, no, I just put it wrongly. Okay, I is equal to 1, and here I should change 0.5 for x naught. 0.5. Okay, so it is run, and here I can see that. Let's run it again. Okay, I run it again. Yeah, so here you can see that, yeah, with 0.5, I got a result of the root of equal to 1. So similarly, in this case, you can put any values, any function, but we need to provide, I think in the modified Newton Raphson method, we need to provide the first and second derivatives as well. So need to change input 3 values over here in each time, and we need to provide it. So that is it. So therefore, I think what you can do is, so when you will do your assignment, I think because this file will be saved as the text file in your hard disk, and for the results part, I think maybe what you can do is you can take the screenshot of the results, okay, and then you can place into your assignment. I think your assignment is very easy. So in this way you will do it. Do you have any questions about these two methods?
So we have to put the code and the output in PDF, yes?
Yes.
Submit.
Yes. Yeah. So for example, right now, if I see that this is my MATLAB folder. So the MATLAB folder will be D MATLAB, and then in that MATLAB folder, I have the codes. What was that code? Modified Newton Raphson Method. Where is this? Yeah. Here you will right click it, open with, and then open with the notepad. So your code will open in the notepad. Okay. So you can copy this code into your Word file. Yeah, you will copy this code into your Word file, and what you can do is the result. If you want to show the result, so you have this. Yeah, so you have this result over here. So you can even copy this result into your. So this is your. Yeah, this is your assignment, and then you can if you want to write any comments, what is the answer, and any want to write any comments, so you can write any comments, and then you can save this Word file into the PDF as well.
Okay, thank
So
you.
yeah, so okay, I only wanted to show to do the coding for these two methods in this lab today. So I will stop at this time, and then maybe you can try to code some other methods by yourself. And then later on, we can also do some more coding in MATLAB. So remember that, of course, in MATLAB, there are very useful commands, okay, by which you can easily find the solution of these equations. But the purpose of coding is that I think it can give you some practice to do some more challenging problems, which you may not solve directly from the command. So, so it's like programming, but at a very maybe not a very high level, but at a very basic level programming. But it can give you good idea of how to do and program your work. Okay. Right. So that's all for today. So any questions?
No,
All right. Thank you. Then let's see you tomorrow in the class then.
thank you. Goodbye.
Okay. Bye-bye.
Thank you. Goodbye.